Hi, this is section 6.4, multiple angle formulas. So here's a list of the double angle formulas. So notice that cosine has three different ones. So just depending on the problem, you get to choose which one seems the most appropriate. Let's look at this first example. It says if sine alpha is 4/5 and alpha is acute, find the exact values of these two. I'm just going to do one of them. I'll do sine. The cosine one is similar. You just choose one of those three formulas. So let's first draw our angle in quadrant 1 since the angle is acute. So an acute angle would be in quadrant 1. There's a 90-degree angle. There's alpha. The ratio is 4/5. That's opposite over hypotenuse. This is a 3, 4, 5 triangle. You can verify that using the Pythagorean theorem. Now that we have the three sides labeled, now we can find out what sine 2 alpha is. So we're going to have to use this formula. So let's do that now. Sine of 2 alpha will be 2 sine alpha cosine alpha. I'm just using alpha instead of u. And now we can use the triangle to fill in these ratios. So 2 times sine, well, we already know what sine is. It's 4/5. It's given to us. Cosine is adjacent over hypotenuse, so 3/5. So if you work that out, you should get, let's see, that's going to be 24 over 25 is our final answer. All right, so sine 2 alpha would work the same way. You get to choose, it doesn't matter which of the three formulas you use, but you will get the same answer for all three versions. All right, let's express 3 theta in terms of just cosine theta. So in this case, we have to get a little bit creative. Another way to write 3 theta would be cosine of 2 theta plus theta. That's 3 theta. And the reason I chose that representation is so that I can apply the sum formula first. So if you recall, the sum formula will look like this. The sum of cosine is alpha plus beta is cosine minus sine. So cosine minus sine. So cosine minus sine. All right, and now we have to use the double angle formulas for this and for this. So for cosine, let's see which one makes the most sense. Because they want it in terms of cosine theta, that means we're going to use the one that doesn't have sine. So 2 cosine squared theta minus 1. And then we bring down the cosine theta. And over here we have sine of 2 theta, which is 2 sine theta cosine theta. And we still have another sine here. So this one I used the formula, the double angle formula, and this sine came down. Now I need to distribute. So if you distribute, you should get 2 cosine to the 3rd theta minus cosine theta minus 2 sine squared theta cosine theta. So I multiplied the sine times the sine, and that's how I got sine squared. Whoops. There we go. All right. The next thing we need to do is get rid of the sine squared because they only want cosine thetas. They don't want sine squared or sine at all. So we need to replace the sine squared. And the way we can do that is to use our identity, the Pythagorean identity, which would be 1 minus cosine squared. So I substituted 1 minus cosine squared for sine squared theta. And now the last thing I'm going to do is distribute in both directions, and that should do it. So 2 cosine cubed theta minus cosine theta minus 2 cosine theta plus 2 cosine cubed theta. So I distributed the -2 and also the cosine. And if there's any like terms, we can combine them. I see these two are like terms, and these two are like terms. So if we do that, we should get our final answer to be 4 cosine to the third. That would get rid of those two. And minus 3 cosine theta. That takes care of those two. That is our final answer. Moving on to the next page, we get formulas for lowering power. So if you want to go from squared to the first power, then you would use these formulas. So let's see, verify this identity. So let's work on the left-hand side. So sine squared, let's replace sine squared with this identity. So 1 minus cosine of 2u, I'll call it x because that's what the problem is using. They're using x instead of u, over 2. And now the cosine one is 1 plus cosine 2x over 2. All right, so notice that you have a 2 in the denominator for both of these. If you factor these out, or if you multiply them, you're going to get 1/4. So I'm just going to bring the 1/4 out, and then I'm going to FOIL this out first, outer, inner, last. If you do that, you should get 1 minus cosine squared 2x. So that's what you get after you expand that out by multiplying. Now you have to use a formula again to reduce this to a first power expression. So we're going to use this formula, but instead of just u, we're going to use 2x. So if you plug in a 2x for u, you're going to get 2 times 2x. So you're going to end up with 1/4, 1 minus. Here I'm going to use another set of parentheses. I'll use brackets here instead of parentheses. So in the place of this, I'm going to write 1 plus cosine of 2 times 2x, which is 4x, over 2. All right, and now let's see. I'm going to rewrite the 1 to be 2 over 2, just so that I have a common denominator. And then I'm going to distribute the negative. So now I have 1/4, 2 minus 1 is 1, minus cosine 4x over 2. All right, and now you can pull out, or you can multiply these two denominators and get 1/8, and 1 minus cosine 4x, which is exactly what we needed that to equal. That is the right-hand side, so we're done. All right, this one is very similar. They're asking us to write this with an exponent of 1 instead of 4. So we're going to have to apply this formula twice. So cosine to the 4th is the same thing as cosine squared. Now let's use the formula. So it's going to be 1 plus 2 cosine t. Right, 1 plus cosine 2t, right? Yeah, 1 plus cosine 2t over 2. And the same thing over here. If you multiply the denominators, you get 1/4 on the outside. And then if you expand these out by foiling or multiplication, you should get 1 plus 2 cosine 2t plus cosine squared 2t. All right, and now we need to substitute for this. We need to reduce that square to a first degree, so we're going to apply the formula yet again. So I'll do brackets again. So bracket here, parentheses here, brackets here. So in the parentheses, I'm going to have 1 plus cosine. Because it's 2t, you have to multiply the 2t times 2 to get, and that gives us 4t over 2. All right, so let's see what we can do at this point. At this point, we're pretty much done. I mean, we could do some simplifying because the whole point was to reduce the 4th power to an exponent of 1, which we've done at this point. But we could simplify this by, getting an LCD. And, well, I'll do that now. So I'm going to change this 1 to be 2 over 2. And I'm going to change this to be 4 over 2, which is the same thing as 2. So 2 over 2 and 4 over 2 for this one. Now I have a common denominator, so I have 1/4. And we got, let's see, we got 2 plus 1 is 3. And then you have 4 plus 1 is 5. All over 2. So I just combined 2 plus 1. That's how I got the 3. And 4 cosine 2t plus 1 cosine 4t is 5 cosine 4t. And the LCD is 2. Now you can multiply these denominators, and that's going to give us our final answer, which is 1/8 3 plus 5 cosine 4t. And that will do it. Okay, let's move on to the next page. So now we have half angle formulas. Notice that these have plus minus. The plus minus is not like the quadratic formula plus minus. In the quadratic formula, the plus minus means there's two answers. In this case, it's either the plus or minus, depending on where, what quadrant you fall in. So you'll see what I mean. So in this one, we're in quadrant 2, because 112.5 is in quadrant 2, and because cosine is negative, that means we're going to use the minus, not the positive. All right, so the way you do these is you have to multiply the angle by 2. So if you multiply 112.5 times 2, you will get 225, and that's your V. So this is going to be the same thing as cosine of 112.5 is the same thing as cosine of 225 over 2. All right, and now we can call 225 our V and use this formula. So we're going to have, we said it was minus because we're in quadrant 2, 1 plus cosine of 225 over 2. Now we can use our unit circle to determine what the cosine of 225 is. So the cosine of 225 is, let me bring up the unit circle. The unit circle is here. Whoops, that's not the unit circle. Okay, let's bring that up. Here it is. 225 is right here. The cosine is negative radical 2 over 2. So negative radical 2 and so I'm going to use that technique of changing this 1 to be 2 over 2. Just so that we can have a common denominator, a lowest common denominator. And so now you're going to have the square root of 2 minus rad 2 over 2 over 2. Well, you multiply these two denominators, that gives you 4, and then the square root of 4 is 2. So you end up with negative 2 in the denominator, radical 2. And that is it. Okay, so let's move on to the next problem. All right, so now we have half angle formulas for tangent. This also works, but I would recommend these two. These two are a little bit more simple. Actually, I would recommend the top one. So let's look at an example for this one. We got tangent alpha is negative 4/3, and alpha is in quadrant 4. Find the tangent of alpha over 2. So once again, let's draw that triangle in quadrant 4. '90-degree angle, alpha. That would be opposite over adjacent. So opposite over adjacent. Negative, notice that I put the negative with the 4, not with the 3, because this is positive 3, and this is negative 4 because it's going down. And this is a 3, 4, 5. Hypotenuses are always positive. And now we can use either one of these. I would recommend the top one. So let's do that now. So the tangent of alpha over 2 is going to be 1 minus cosine of alpha over sine of alpha. Cosine of alpha is adjacent over hypotenuse. So that's going to be 3/5. The sine is opposite over hypotenuse. And remember, we can change this one to be 5 over 5 to have a common denominator. And so we end up with 2/3 times the reciprocal, negative 5 over 4. You get some cancellation here. And so you end up with negative 5 over 6 as our final answer. And that completes the